In this video, I'm going to find the cross product of the vectors u and v. So we are given those two vectors there, u and v. I'm going to use the determinant. When we are using the determinant, we have the cross product of u and v is equals to the determinant of that 3 by 3 matrix there. So what I can write there, I can write my u cross v, and we'll be taking the determinant. In the first row, we put our unit vectors at the I, the j, and the k. In the second row, what we are having here, we put the elements of the first vector u. So the elements of the first vector u are these ones. So put a 2, a 1, a 1. On the third row, we put the elements of the second vector, the v. So the elements there, -4, 3, 1. I now go on and evaluate the determinant of that 3 by 3 matrix. And to evaluate that determinant, I'm going to use the cofactor expansion method. And I will expand using the first row there. So when expanding using the first row there, I will start by looking at the sign factor. For the sign factor, we have the array of positive, negative, positive, negative. So if we look at the I there, its corresponding position is this one. First row, first column is a plus. So it corresponds to a plus there. The J corresponds to this one. First row, second column, it's a minus. The K corresponds to this one. First row, third column, so it's a plus. So I now have my sign factors there. I will now go on and look at each of those elements in that highlighted row. So I'll start with, I close the row and the column, and then multiply it by the determinant of the uncovered elements. Then the determinant of the uncovered elements there are 1, 1, 3, 1. So I'll write there my 1, 1, 3, 1. I will now go on to the next element in the row there. We are now looking at the J. So for the J, close the row and the column containing the J. And the J is sitting on a negative there, so it will be minus J multiplied by the determinant of the uncovered elements. The uncovered elements there are 2, 1, -4, 1. So I can write there my 2, 1, -4, 1. I will now go on to the next element, the K. So I close the row and the column containing the K, and the K there is sitting on a positive, so write there plus K multiplied by the determinant of the uncovered elements. The uncovered elements here, they are 2, 1, -4, 3. We now have those 2 by 2 determinants there. So I will now go on and evaluate the determinant of this matrix there. When you have a 2 by 2 matrix, the determinant of the matrix A, B, C, D is given by AD minus BC. What this formula is saying is we multiply these two elements, then subtract the product of these two elements. So we are saying I multiplied by that determinant. So it will be I multiplied by 1 times 1 minus 1 times 3. I'll now go on to the next determinant, this one here. Using this formula is saying that that's the product of these two elements minus the product of these two elements. So we have the minus j there multiplied by 2 times 1 minus 1 times -4. I now move on to the next determinant, this one here. What this formula is saying is we take the product of these two elements, subtract the product of these two elements, and our result there will be k multiplied by 2 times 3 minus 1 times -4. So the next step now is to simplify what we have there. So if you look at what is in the square brackets here, that's 1 times 1 minus 1 times 3, which is just 1 minus 3, which gives us a -2. So we'd have -2i. Now on this part, looking at what is on the square brackets there is 2 times 1 minus 1 times -4. So that will give us 2 plus 4, which gives us a 6. But we have a minus sign here, so it will be minus 6j. Then I go on to this part here, simplify what is in the square brackets. That's 2 times 3 minus 1 times minus 4. That gives us 6 plus 4, which is a 10. So that will be plus 10k. So what you are having there, the cross product of these two vectors is minus 2i minus 6j plus 10k.